In this video, I'm going to show you how to do Edexcel A-Level Maths, June 2022, Paper 1, Question 9. My name is Sunil Tanna. I am a tutor and author. I live in Buckinghamshire, England. I'm available for one-to-one tuition, both online and in person. Please don't forget to like and subscribe. This question is kind of interesting as at least the second part of this question, part B, there are at least 4 different ways of doing it, only 3 of which I'm aware of being shown in the mark scheme, although they're all valid. So I'm going to show the 3 ways that are perhaps the most obvious ways to do it. The first one is perhaps the most obvious way that's covered directly by the maths syllabus. The other ones require additional knowledge. Okay, let's read the question now. Question 9, we have this shape here, PQRS. It looks sort of like a rhombus. It might not be a rhombus. It says figure 3 shows a sketch of a parallelogram PQRS, given that PQ is equal to 2i plus 3j minus 4k and QR equals 5i minus 2k. Show that the parallelogram PQRS is a rhombus. So knowing that it's a parallelogram, we know that the opposite sides will be the same vector. So QR will be the same as PS and PQ will be the same as SR. But we don't know it's a parallelogram, a rhombus specifically, which is a subtype of parallelogram, unless we prove that the adjacent sides are the same length. So what we can say is we can work out the magnitude of the adjacent sides. So we can say that, for example, let's say for part A, PQ, the magnitude of PQ is the square root of 2 squared plus 3 squared plus minus 4 squared. And if we work that out, it comes out as equal to root 29. Yeah. We also know that the magnitude of QR is equal to square root of 5 squared. There's no j component or 0 squared, and then plus minus 2 squared, which is root 29. We also know, because it's a parallelogram, the magnitude of SR is equal to the magnitude of PQ, because parallelogram. Likewise, the magnitude of PS is equal to the magnitude of QR, because parallelogram. So now we know that all the sides are root 29 long, so all sides are length root 29, which is the same, so therefore it's a rhombus. Okay, part B. Find the exact area of the rhombus PQRS. So the whole thing, so the way to do this really is to divide it up into 2 triangles. All the methods I'm going to show rely on that. So we already have been given this vector, and we have been given this vector, and we've worked out the length of this side is root 29, and the length of this side is root 29. So what we can do is to imagine a line from there to there, PR. And we can see that PR would be the sum of PQ plus QR. So I'll write it here at the bottom. PR is equal to PQ plus QR. And if you add the I components together, you'll end up with 7. I'll write it as a column vector. If you add the J components, it's 3 and 0, so it adds up to 3. And if you add the K components, it's minus 4 and minus 2 is minus 6. So now you can see the magnitude of this PR component, PR vector, is the square root of 7 squared plus 3 squared plus minus 6 squared. And you put that all together and it's root 94. So this side here is root 94. Now if you know 3 sides of a triangle, you are able to do the cosine rule to find this angle here. And then what we're going to do then is use the sine rule to work the half AB sine C formula to work out the area of this triangle, and then double it to get the whole area of the rhombus. Okay, so using the cosine rule, which is cos A is equal to b squared plus c squared minus a squared over 2bc. And if I draw that triangle again, what we're saying is that this angle at the top here is A. So A is the same as PQR. This side here will be A, which is root 94. And we can call these ones B and C, root 29 and root 29 are B and C. So if we fill that into the formula, those numbers, I won't write out every single number in there. So b squared would obviously be, actually maybe I will. B squared is root 29 squared, which is 29, plus another c squared is also root 29 squared, so 29. A squared is root 94 squared, so minus 94. And then 2bc is 2 times root 29 times root 29, which is 58 if I put that in. All right, so you end up with minus 18 over 29 once you simplify it. Now, if you know cos, you can use 1 minus cos squared is to get the sine squared, or sine of A is equal to the square root of 1 minus cos squared A. So if you do that, so here we're going to do the square root of 1 minus 18 over 29 squared, which will give us the cos of the angle sine of the angle we have, which is root 517 over 29. Yep. And now we're going to do the triangle again. We're going to do the area of the same triangle. We're going to use the half AB sine C. But now here, see the angle that was A before, which was PQR, is now C. C is PQR. So now this side over here is C, and these are your A and a B. So using that formula, so half AB sine C is going to be a half times root 29 times root 29 times sine C is root 517 over 29, and if you put that in, you'll get root 517 over 2, and of course the area of the rhombus is two equal triangles, so let's double that. Area rhombus is root 517 over 2 times 2, which will give you root 517, which is your final answer. Okay, I'm now going to show you how to do 9b in another way, using the dot or scalar product, which you learn in further maths. It's very, very simple, really. So here's B again. I won't write out part A again. So the dot product here is when you multiply two vectors together, A dot B, what you do is you'll find that you get the answer, which is just a scalar number, is the magnitude of the first vector times the magnitude of the second vector times cos of the angle between them. So if this one was A and this one was B, we'll be able to find this angle here, and then after we've got that, we can repeat the half AB sine C formula to get the area of the top triangle and then double it. Okay, so so here what we're going to do is work out the scalar product. So the scalar product here is 2, 3, minus 4, dot 5, 0, minus 2. So the magnitude of the first one we worked out already was root 29. The magnitude of the second one is root 29, and the angle between we'll say cos theta. Now there's another way of working the scalar product, because we don't know what theta is, which is to multiply these together. So we do 2 times 5 is 10, 3 times 0 is 0, and minus 2 times minus 4 is 8. So here we're going to get, this time we're going to end up with cos theta is 18 over 29. Right. The reason here that you might have noticed in the previous question it was minus 18 over 29. The reason here is, of course, they're actually these vectors meet at two angles. There's an obtuse angle here and an acute angle here, and we've actually found the acute angle this time. But it doesn't matter, because when we do 1 minus cos squared to get the sine angle, it's still going to come out to the same result. So here we can say, just like before, we'll say sine theta is the square root of 1 minus cos squared theta. So it will be the square root of 1 minus 18 over 29 squared, which came out as before to root 517 over 2. And now we're going to use the half AB sine C formula. So this is our triangle here. If I draw it here, this is PQR. This is our C, that's root 29, which is our A, small a. This is our root 29, which is our small b. Obviously, this is our little c. So the area of triangle PQR is half root 29 times root 29 times sine theta, which we know is root 517 over 2. Right, and if we put that in, we will get the area of the triangle is root 517. So, yeah. Sorry, that's wrong. The sine theta is root 517 over 29. I wrote that wrong here. Okay, and then, so then this one, the area comes out to root 517 over 2, which is a triangle, and then the rhombus area is 2 times root 517 over 2, which gives you root 517. Okay, and that gives you the area of the whole thing. Another further maths method that you may know is to use the vector product or the cross product to work out angles, but I'm going to skip that one because not everybody who does further maths probably is aware of that at this point. I'm not sure if it's in everybody's syllabus. So what we'll do is we'll show you a third method, which is not actually in the mark scheme, which is called using Heron or Heron's rule. You'll be able to find the formula for this in Wikipedia and elsewhere, but I will explain it here in a minute. Okay, so the area Heron's rule or Hero's rule, I'll write it here. It's spelt both ways. It's one of these Greek mathematicians from BCE times. So Heron's or Hero's rule. You can work out the area of the triangle. The area of the triangle is given by this formula: the square root of s times s minus a times s minus b times s minus c. Well, s is what we call the semi-perimeter. It's half the perimeter, and then a, b, and c are the lengths of the three sides. So if we were to work out this triangle, as before, we work out this one was root 29, this one was root 29. If we work out PQ plus QR, which we did before, and then work out the length of this line, it will come out to root 94. So the semi-perimeter, S, will be root 29 plus root 29 plus root 94 divided by 2, which is root 94 plus 2 root 29 over 2, which is slightly awkward, yeah, but it's still solvable because the area now of the triangle, the area of PQR, is going to be the square root of S, which we've got up here. Now, if you've got this in your calculator, you just put this into your calculator and press equals, it'll be the answer. So I'll just write it as S, but you would, on the calculator screen, it would say answer, and then times answer, or S, minus root 29 times answer, which is S, times root 29 times answer, S minus root 94. Now, if you were to, you can work that out by hand. It takes quite a bit of rearranging, but it is doable. But if you do it in your calculator, you will find it comes out to root 517 over 2. And of course, the area of the rhombus is root 517 over 2 times 2, which is root 517. And that completes question 9 in 3 different ways. Obviously, the first way of doing 9b is the simplest way that you have covered in your A-level maths, probably the first year, and maybe even in GCSE, you should have done the cosine rule. Okay, thank you.